The next type of word problem we are working on is word problems relating two different objects to each other. So this is best used with standard form. So let's recall that standard form is ax plus by equals c. And a, b, and c are numbers. So we are going to use this variation when the problem relates two different objects. So for example, in the first one here, we have hamburgers and hot dogs. So Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His total bill came to $19.05. If hamburgers cost $5.25 each, so that's a multiplication word, write and solve a linear equation to find the cost of each hot dog. So we're looking for cost of hot dogs. So we have two, we can't use H and H, so I'm going to use X for hamburgers and Y for hot dogs. So let's see, let X equal hamburgers and let Y equal hot dogs. And we could use A and B or I don't know, F and G or something. Okay, so they told us he bought 2 hamburgers and 3 hot dogs for a total cost of $19.05. So now you can see why it's easier to use standard form with this type. And then they gave us another hint and told us that the hamburgers cost $5.25 each. So I'm going to take out X and replace it with the $5.25. So 2 times $5.25, which is the cost of each hamburger, plus 3 times the unknown number of hot dogs, or the cost of each hot dog, equals $19.05. So 2 times $5.25 is $10.50, plus 3y equals $19.05. And let's subtract $10.50 from both sides. These cancel each other out. I have 3y equals $8.55. And then divide both sides by 3. Divide by 3. 3's cancel, and we get the cost of a hot dog is $2.85. So if you got some really crazy or run-on decimal or a negative number here, you probably did it wrong. It's money, so it should come out to the hundredths place. So something to keep in mind there with money. All right, number 6, and we're still working with standard form here. Tickets at a school play cost $4 in advance. That's key information, so circle it, underline it. $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find out how many were sold at the door. So because we're comparing 2 pieces of information, 2 types of tickets, it's best to use a standard form equation here. So I know I'm going to use A for advance. Let's see, let A equal advance tickets. You could use X's and Y's, it's fine. I just know where this is headed. Let D equal door tickets. So we're in algebra. We need to be able to use different variables for different unknowns. So $4 times the number of advance tickets plus $5 times the number of door tickets brought us in a total of $440. And no tickets were sold in advance. So I'm going to take out the A and replace it with a 0 because no tickets implies 0 tickets. plus $5 times the number of door tickets brought in $440. So anything times 0 is just 0. So I'm just going to bring down the 5D for $5 times the number of door tickets brought in $440. I'm going to divide both sides by 5. And I have the amount of money at the door was 88 tickets. And I put my D on the left, but you can have the D on the right. It doesn't matter. All right. Karen's piggy bank has all dimes and quarters. All right. Dimes, quarters, nickels are not going away. Guys, you need to know how much they're worth in decimals. A dime is worth 0.10 cents. Okay, keep that in mind. A quarter is worth 0.25 cents. A nickel, which I don't think we have any in this problem, but just for future knowledge, is 0.05. Okay, so just keep that in mind. A dime is 10 cents, a quarter is 25 cents, a nickel is 5 cents. And that's how you write it using decimals. The total value of the money in her piggy bank was $11.40. If Karen has 36 quarters, write and solve a linear equation to find the number of dimes she has. So our unknown is the number of dimes. We're looking for D. All right. Because we're comparing two things, dimes and quarters, it makes most sense to use the standard form equation here. So we know she has 36 times quarters plus an unknown number of dimes. Let's see. So 36 times 0.25 plus the unknown number of dimes, so D, times 0.10 for a total of $11.40 in her piggy bank. So 36 times 0.25 would be $9 in quarters, plus, I'm going to move the number in front of the variable here, 0.10D, 10 cents times the number of dimes equals a total of $11.40. So let's subtract this 9 from both sides to see how much money is made up of dimes. These 9's cancel, and I have 0.10 times the number of dimes is $2.40. And then divide both sides by 0.10. And that tells me she has 24 dimes. The Oakville High School marching band sold gift wrap to earn money for a band trip. Solid color gift wrap sells for $3.50 per roll. There's that multiplication word per, and that is for solid. And printed gift wrap sells for $5 per roll. The band needs to earn $2,500 for an upcoming competition. If the band sells 325 rolls of printed paper, write and solve a linear equation to find the number of solid paper rolls that they must sell. All right, so since we're comparing two things, printed and solid, it makes most sense to use the standard form equation. So we know that, let's let S equal the number of solid rolls. Let's let P equal the number of printed rolls. And yes, you could absolutely use X's and Y's here. It's absolutely fine. So we are going to do 350 times the number of solid rolls plus $5 even times the number of printed rolls, and I could have just used a plain 5. That's fine. It has to be sold for $2,500. But we know how many printed rolls, so we're going to take out the P here in a second. So 5 times 325 rolls of printed paper So 2,500. All right. So 350 S plus the total amount of money that came in from the printed rolls was 1,625 equals $2,500. And we're going to subtract 1,625 from both sides. And we're left with $3.50 times the number of solid rolls brought in $875. And if we divide both sides by 350, you have the number of solid rolls would be 250 rolls of solid paper.